Hey folks, how we doing today? Okay, we're looking at review number 4. This is going to go pretty quickly, um, so I suggest that you use the pause button and try to do the work on your own and then check it. Use it to check. So anyway, let's get started. It's talking about finding derivatives. And in order to do this, what we're going to do is use the power rule. And all we're going to do is take that 3, bring it out front, multiply it, and then lower the power by 1. And keep in mind, with constants, we're not going to use. So with this other one, number 2, we're going to use the chain rule, and it works pretty much the same way. We're going to bring the 3 down in front, and then we're going to multiply it times 2x plus 4 to the second, but then we're going to also multiply it by the derivative of the inside. And then that'll give us this. All right, now we're talking about integration, and an integration is the undoing of a derivative. And the way we do that is we take the power and then we make it bigger and then multiply by the reciprocal. And then we do that for each term. And then keeping in mind, when you have a constant in your derivative, you just got to put an x with that. Now the other thing you've got to keep in mind is that you have to put a plus k on the end for a constant that we can't figure out. You'll notice that this is the same as the original, but we can't do the 5. We don't know what it is without more information. So now when we do this, we're just going to undo the chain rule. We bring up the 2 to a 3, multiply by 1/3, and then we also multiply by the reciprocal of the derivative in the inside, and we end up with this. And again, you've got to put a plus k at the end because there could be a constant that we can't figure out right now. So then, of course, it can get a little more complicated. We've just got to rewrite this so the powers are in the numerator by bringing the x squared up and making it negative. And see, now it's still the same process. All I've got to do is take each term, raise the power by 1, multiply by the reciprocal of it, and then when I get done, put a plus k or a plus c at the end to make sure that people know that there could be a constant. And then this is just means, it's a notation, and it just means integrate this, integrate the thing after this. So if you see something like that, it just means the same thing. And again, we've got to bring this up to the top in the numerator, so we make the power negative. And now we just take that negative 1/2 and make it bigger by 1, and then multiply by the reciprocal. The same thing we just did above. What we're going to end up with is this. And again, always remember that when you're done, you have to put a plus k on there, unless there's some boundaries or a point that we know about. Now, in this question, what's different is they're giving us a point on the original equation, and they're asking us for the actual equation. And so I start out the same way. I'm going to integrate, and then what I'm going to have to do is find out what that k is. So we start off, this is going to be x to the 3rd, but then I multiply times 1/3. And you don't have to write all this. I'm just doing it to make sure you can see. But most of the time, a lot of times you could tell what it's going to be. 3 times 1/3 is just going to be 1, and I would probably just write that on my own. But anyway, this goes step by step. We raise this to a second power and then multiply by 1/2, and then it'll be 4 times 1/2. And then when you get to the end, you see the constant. It's a 3, so just make it 3x. And so then we have to make our plus k here. And then all we've got to do is clean this up, multiply everything, and this gives us the indefinite integral. So it's going to have a plus k at the end. Now, this is almost the function, the equation that they want. What I need is to find out what k is. And since they've given me a point, all I got to do is substitute the x and the y from the point, and then I only have one thing I don't know, and that's going to be the k. In a problem like this, either they're going to hand you a point or they're going to give you a way to figure out the point. But if you need the actual equation, you're going to have a point that was on the original function. Anyway, in this case, we find out that k is equal to 4, so the original function was this. Now, in this next one, you'll notice that they're referring to a minimum. A minimum value is a stationary point, and we know the slope is equal to 0. and they want us to find the equation of the curve. And so we start off with the derivative, and we go ahead and integrate that, just like we were doing before. And then we'll get this 2x squared minus 12x plus k. Now the thing is, I need a point to plug in here, and I have a y. They tell me it's 16, but I need to know what the x is. Well, because it's a stationary point, I know the derivative has got to equal 0 at the stationary point, and so I can find out that the x is a 3. And see, then all I got to do is substitute that in, find out my k is 34, and then plug that back into my original, and I get 2x squared minus 2x plus 34. Now, this next one, number 9, again, we're just making it a little more fancy. You got to clean this up, bring the powers in the numerator, and then just do the same thing we were doing a second ago. Raise the power by 1, multiply by the reciprocal. Raise the power by 1, multiply by the reciprocal. When you get done with all the terms, put a plus k at the end. If you're actually finding the original equation, then you need a point. In this case, it's 420. We substitute the 20 in for y and the 4 in for x. We find out that k is equal to 6. And then we get the original equation is this, which could be written this way with powers, or we could go ahead and undo it, and it would be the square root of x to the third minus 8 over x. All right, now in this one, they're giving us the derivative, it's 4 minus x, and they want us to find, they tell us the normal meets at P, and they tell us point P, and it meets the curve again at Q, and they want us to find point Q. So in this case, what we've got to do is we've got to figure out the tangent slope, which is what we can use the derivative for. We find out the tangent slope is going to be 2. Now, the reason that's important is because now I can figure out the normal slope. The normal is just perpendicular. So I know the normal slope is negative 1/2. And so now all I've got to do is find the equation of a line, substituting the point I know, 2, 9, and I found out the y-intercept is 10, and so my normal equation is going to be negative 1/2 plus x plus 10. Now I'm going to have to find the original equation, because remember this point Q is where these two things meet, the normal and the original. So now I'm going to do like what I've done before. I take this, I find the integration, and then I plug in the point so I can find the actual original equation, which is going to be k is going to equal 3. And so I'm going to find out that it's going to be 4x minus 1/2 x squared plus 3. Now, that's the original. And this point Q is where these two guys meet. So I have to solve them simultaneously. And they both equal y right now. So all I'm going to do is make each rule equal to each rule. And then it really just becomes a process of getting, it's a quadratic obviously, so getting the square term on one side with everything else, and I'd like the square term to be positive. I'm running out of room here, but I'm going to take this and double it to get rid of that fraction. And see, now all I'm going to do is factor it, and I'm going to find out x minus 7, x minus 2 is equal to 0. Well, you'll notice I got x plus, or is equal to 2. That is already the point I know. That's the tangent point. Obviously, they have that in common. This is the other point that I need to know. That's 7, 6.5. All right, now, integration can also be used to find the area between the curve and the x-axis. And in this case, they're going to give you boundaries. And it'll typically be written like this. And remember, the bigger one's on the top and the smaller one's on the bottom. And then this other part's just a notation that we use. And what happens is we make a function, and what we do is we make a function and we plug in both boundaries and subtract them. Substitute in the function of the bigger one, and then substitute the smaller one. So anyway, let's take a look at this. Here we've got this curve. We're going from 2 to negative 1, and this is the curve I want to do. So all I got to do is integrate this, make the power bigger, multiply by the reciprocal, each term. And see, now I'm going to put this in this notation I've used before, and all this is saying is that's my function. I'm going to plug in a 2, and I'm going to plug in a negative 1. So when I substitute a 2 in for all those x's, I get 24. And when I substitute a negative 1 in for all those x's, I'm going to get a negative 3. Now keep in mind, I'm subtracting them. So it's 24 minus a negative 3, which is equal to 27 square units. Now, then number 12, we've got to get these powers up in the numerator. So we just rewrite them so they have negative exponents, but at least the powers in the numerator. And then we proceed like we were just doing. I raise the power by 1 and multiply by the reciprocal. Raise the power by 1 and multiply by the reciprocal. And see, that gives me this as my integration function. And again, just to save myself a little bit of work, I'm going to use the notation, and I'm going to use these boundaries. So all I'm going to do is substitute the 2 in and the 1 in. And what I get is this. All right, so here we've got a quadratic, and we need to find the area between the curve and the x-axis. And if we do a quick sketch, we find the zeros. This is pretty easy to do. I find out that x is equal to 0 and x is equal to negative 3. And so I know that this quadratic is going to kind of go like this. And see, the point of this problem is that when I'm finding the area between the curve and the x-axis and it's above the x-axis, it's going to be positive. But when I find the area below the x-axis and the curve, well, then it's going to be negative. But I still represent it as a positive area. So what I've got to do is do them separately, and then add them together after I take the absolute value of the negative one. So anyway, I've got this. I'm going to take this, and then I'm going to use these boundaries, 2 and 0, and then I'm going to do the same thing, same function, only I'm going to use the boundaries 0 and negative 1. So anyway, let's start with this. If we raise the power and multiply by the reciprocal for each term, we get this. And all we got to do is clean it up a little bit. And then we set it in the notation. And I'm going to use the boundaries 2 and 0. And when I do that, I get 26/3. Now I'm going to do it with the other one. But keep in mind, when I'm done, I expect this to be a negative area. And so then I'm going to take the absolute value of it. Anyway, when I use the same thing, I put in 0 and negative 1. I find out it's negative 7/6. But when I take the absolute value of it, it's 7/6. Now, remember, now I've just found two areas. I'm not subtracting these. I'm adding them together to find the total area. Now, in number 14, basically I've got two different ways I can solve this. This could be considered the area between two curves. And it also could be considered, I could find the area of 6x squared wrapped around the y-axis as a boundary. So there's two different approaches. It's quite honestly easier to do it between two curves, but I wanted to show you the around the y-axis too. So let's start with between the two curves. Well, the thing is, I only have one curve. I need to know the equation of the horizontal line that's setting that top boundary there. And so all I've got to do is plug in my 5, and I find out that that point is 5, 150, which means that horizontal line is y equal 150. And to find the area between two curves, all I got to do is subtract the higher one, the one above it, minus the one below it, and then find the integration of those. So in this case, it's 150 minus 6x squared. And then all I got to do is do the integration of that. And I get this as my function, and I'm going to plug in 5. I'm going from 5 to 0. And when you do that, you'll find out that it's 500 units. Now, the other way to do it is bounded by the y-axis. And the thing is, in order to do that, I need to solve for x. I need the rule written as y's. So anyway, when I solve for x, it's going to equal the square root of y over x. And if I separate that, it's the square root of 1/6 times the square root of y, or y to the 1/2. And see, now if I do integration with that, all I'm going to do is add 1, and I get 1/2 plus 1 is 3/2, and then multiply it by the reciprocal, and I still have a square root of 1/6 out there. And that looks a little bit crazy, but really all I'm doing is plugging numbers in. If I plug in my boundaries of y equals 150 and 0, I'm going to get another 500 units squared. Now this next one, we're actually literally finding the area between these two curves, and it's pretty clear. You got to be careful. The one curve is not written with y equals, but you'll notice right now that we need boundaries, and so we've got to find those. And The way to do that is to take these and solve them simultaneously. And the way that looks is I've got these two functions, and they're both equal to y already, so I make the rules equal to each other. And I got some multiplying to do, and then I just got to get everything on one side. It's a quadratic, and the way I solve the quadratic is by factoring, if it's possible, if not, the quadratic formula. And I find out that x is equal to 3, x is equal to -1. Those are my boundaries. Now I got my boundaries, I can go ahead and I can take my two functions and subtract them. The rule of the one function is, whoops, be careful. The rule of the one function is 7 minus 2x, and the rule of the underneath function, I already know it and I've already multiplied it, so I'm just going to write it that way. But keep in mind, I'm subtracting all of it. So what I end up having is going to be 7 minus 2x, but it's going to be minus x squared and plus 4x and minus 4. Anyway, all I do is clean that up, and then I just got to integrate that between the boundaries that are set. And when I do that, again, we're maybe raising the power and multiplying by the reciprocal. Do that for each term. And then my boundaries are 3 and -1. And I end up with 9 minus a -5/3, which should equal 10 2/3 units squared.